So it's 11:40. Let's get started. Welcome to this session on SQL Server and Kubernetes. I want to say thank you to the sponsors, and we also want to point out that there is a photo contest on the official Facebook page of SQL Day as well, so go and check that out. Okay, a little bit about myself. My name is Andrew Pruski. I'm a SQL Server DBA, Microsoft Data Platform MVP, and Certified Kubernetes Administrator. I'm originally from Swansea, Wales, but I've been living in Dublin, Ireland for coming up to 7 years now. My Twitter handle and my email address are on the slide there. So if you have any questions after today, please feel free to reach out. I'm always willing to talk about this stuff. My blog's there as well, dbafromthecole.com. I've written multiple articles about running SQL Server in Docker containers and on Kubernetes, some of which I'm basing this session on, but others go into a little bit further information. So if you want to check that out, you're more than welcome. And then finally, my GitHub account. All the slides and the code for the demos that we'll be doing today are on my GitHub account, and I'll post a link to the actual repo at the end of the session. Okay. The aim of this session is to give you some background knowledge of how Kubernetes works and some code so that you can go and get started with deploying SQL Server to a Kubernetes cluster. So we're going to have a look at running Kubernetes locally on Docker desktop, spinning up an instance of SQL Server, blowing it away, playing around with it. Then we'll look at some persistent storage for SQL Server running on Kubernetes because, hey, we're SQL Server folks. Persistent storage is important. And then we'll have a look at a package manager for Kubernetes called Helm. And then we'll have a bit of fun at the end of the session, and we'll do some chaos engineering for SQL Server running on Kubernetes. But first things first, what is Kubernetes? Now, the definition there is from the Kubernetes IO website, and it says that Kubernetes is an open source platform for managing containerized workloads and services. Great. What about Docker? Isn't Docker a platform that we can manage containerized workloads and services? What's the difference? Well, with Docker, you have one server where you deploy Docker and you run your containers on it. What happens if that server goes down? You've got a single point of failure there. With Kubernetes, we have the option of having a fleet of servers where we can run our containers hosts. So we have that built-in high availability. If one node goes down, our containers get moved to another server. And we don't typically say to Kubernetes, hey, I want to run here or here or here. We just have to tell Kubernetes, hey, we want to run something, and we let Kubernetes sort it out in the background. So a little bit of background on Kubernetes. The word itself is Greek. It means helmsman or pilot. And I only bring that up because it explains the logo. It's open source, so you can go and view the code on GitHub. It was designed by Google and is now hosted by the Cloud Native Computing Foundation. And version 1.0 was released in July 2021, 2015. So we're 5 years old at this point. A little tidbit, it was originally, its code name whilst at Google was 7 of 9. And if you believe some stories, that is the reason there are 7 spokes on that wheel on the logo. But of course, due to copyright, they had to change the name when they went GA with it. So it was renamed Kubernetes. But the biggest question I get when it comes to using Kubernetes, especially when it comes to SQL Server, is why? Why would I want to use Kubernetes? Think about all the platforms we have for running SQL Server. We have physical servers, virtual servers in the cloud, Azure SQL DB, Amazon's RDS. We even have managed instances. So why would I want to run SQL Server on Kubernetes? Let me tell you a story. A couple of jobs ago now, I was working with a QA department who were having problems refreshing their test VMs. And they did this on a periodic basis, say, well, I think it was between every month or 2 months, where they blew away the whole environment and rebuilt. These VMs had the entire production stack on, which meant each one had to have an instance of SQL Server. And SQL was deployed via Chocolatey and then configured with a bunch of PowerShell scripts. And it wasn't the most reliable process in the world. It was prone to failure, and it wasn't the quickest process in the world. We're talking anywhere between an hour to an hour and a half just to get SQL, just the database engine, installed. And this was due to the hosts they were on. They were really old disks, old CPUs. So there must be a better way. And we used containers. We got rid of all of the instances on the QA hosts and replaced them with a remote host running Docker containers. So their process then just built the application stack on the VMs and went off and spun up a container running SQL Server on the remote host. And it dropped the container, dropped the build time considerably. I think we actually worked it out that it was saving a month of dev work every year. But we were running on that one host. That was a single point of failure. And this did happen a couple of times. If we came in and the server went down, none of the QA people could do any work until we brought that server back up and respun up all their containers. If we'd been using Kubernetes, one of those hosts would have failed, everything would have moved to another one, the work could have continued. We'd have had that built-in high availability. So why learn Kubernetes? It is the leading orchestrator out there. There are other options. There are things like Docker Swarm, Mesosphere IO. I can't remember the name of it off the top of my head now. But there are other options. But Kubernetes is definitely the leading orchestrator in the market. We have the ability to easily deploy and maintain containers. It's really quick to spin up containers. SQL will come up, especially in Docker Desktop, which we'll show you later, will come up in a second. We have that high availability built in. And if you're looking at SQL Server 2019 big data clusters, Kubernetes is the technology that it's built on. So if you want to learn that, and Azure Arc as well, the new product that's come out, have a look at Kubernetes. Understand the underlying infrastructure will give you a much better knowledge of what's going on in those technologies. So let's go ahead and let's have a look at deploying SQL Server locally into Docker Desktop. Now, there are other technologies out there. There's Minikube. If you check out the Database Avenger, James Anderson's blog, he's got a great blog post on running Kubernetes in Minikube. I would personally prefer using Docker for Desktop now because it's so easy to get spun up. It's literally just a tick box in the Docker settings, and you have a Kubernetes cluster up and running. If you're running on Linux, you can use MicroK8s, and I have a laptop down here that runs Ubuntu, and MicroK8s is fantastic. It's really simple to get up and running with it, and you have a one-node Kubernetes cluster all running on your local machine that you can deploy into. There's also K3s, which is like a lightweight version of Kubernetes. So you can deploy that locally if you're on Linux, or if you want to run it in a VM, really, really handy. And then there's Raspberry Pis. I've actually got a Raspberry Pi cluster running just over there. 4-node cluster with provision storage, so I can deploy anything I want to and play around and tinker. And it's really good to learn all the bits and bobs of how Kubernetes fits together. If you want to learn how to build your own Kubernetes cluster on a Raspberry Pi, I published a blog on Monday, which will take you from the very start of flashing SD cards for your Raspberry Pis to installing Kubernetes and running Azure SQL Edge on it, because it's ARM. So Azure SQL Edge is deployable on ARM, SQL Server isn't. But kind of the same thing. I think Microsoft wouldn't like me saying that, but you can get SQL Server up and running on a Raspberry Pi using Azure SQL Edge and Kubernetes. So we have other tools as well. I'm going to be using Visual Studio Code to deploy my code. You can also use Azure Data Studio and Management Studio to connect to SQL Server once it's up and running. We have kube control. This is the command line tool that we use to administer our Kubernetes clusters. And the bottom one there is the MS SQL CLI. This is like SQL command on steroids. It has some really good stuff based on Python, and it does really cool things like IntelliSense, and it formats the output a lot nicer than SQL command. So I highly recommend you check that as well. But let's get going, and let's do our first demo of getting up and running with SQL Server in Kubernetes. So here I am in Visual Studio Code. I'll just have some water here. Now, to spin up SQL Server in Kubernetes, we need to use a container image. Now, Microsoft used to put all their SQL Server container images on the Docker Hub, which is really cool because we could use like Docker search or go to the Docker Hub and search on the website and have a look at all the images there. They've since moved to their own container registry, the Microsoft Container Registry, the MCR, and that doesn't have a website that we can go and search, but we can do things like this: invoke web request, and then have a look at the content. And we can have a look at all the tags here, and we can see all the different versions of SQL Server that are available to us. And so the latest one here is CU8 OD2. Okay, I'm not sure what that is, but I'm going to go with 2019 CU5 Ubuntu 1804. And this is the Microsoft SQL Server 2019 CU5 for Ubuntu 18.04 image. Now, I've already pulled that down. So if we have a look here, oh, there we go. We can see that it's in my local registry. If I close that, maybe it'll look better. Haha, there we go. Let's do this. There we go. So I've got a whole bunch of Kubernetes objects here. These are all the bits and bobs that get a one-node Kubernetes cluster running in Docker Desktop, but I have my Microsoft SQL Server 2019 CU5 image there. So let's go ahead and let's deploy it. So I'm just going to make sure I'm pointing at the right cluster, Docker Desktop, excellent. And I can do kube control get nodes, and it'll show me all the nodes in my cluster. And there we are. I have my one-node cluster running everything. So now I can deploy SQL Server. So I say kube control run something called SQL Server from this image, the Microsoft SQL Server 2019 image, accepting the end user license agreement, which we have to do every time we run SQL Server in a container, and then setting an SA password that we're going to use to connect. So if I run that, you can see that that pod is created. We'll come to what a pod is in a minute. And there we go. We can see that it is up and running. How quick was that? So what I can do now is I can jump into that pod, navigate to where SQL command is, connect to SQL, and I can run a command, simple command to say, hey, what version are you running? And there we are, Microsoft SQL Server.
Excuse me, Andrew.
Yes.
We're receiving the information from our attendees that there is some issue with low quality. It's not happening to me, but I trust them. And the reason for this is something I advised you before, enabling optimization for a full screen presentation. Could you please disable it and try if that would fix the issue?
Okay, I've just disabled that. Is that any better? Yep, so it is that setting that, okay.
Much better. Yeah, so it was me. I'm sorry.
No problem. Okay, where
please
were we?
Continue.
No, so okay, no worries. I've never turned that setting on before, so I wasn't too sure what it did. Now I know. Okay, so what we've done so far, if everyone can see the text here, is we've spun SQL Server up. We've navigated to where SQL command is in the container running SQL Server, and we've just run a simple command. There we go. Can everyone see that? Does that look okay? Just watching the chat here. Excellent. Thank you very much. Okay. Okay, so we have that up and running, but it's kind of naff because we don't want to be spinning stuff up and having to exec it, navigate to where SQL command is and run commands like that. What we want to do is connect from our local machine directly into it, like we would any SQL instance. So what we can do is expose that SQL instance using kube control expose pod SQL Server, type a load balancer again, which we'll come to, but specifying our ports, port 1433, port 1433, the default port that SQL Server listens on. If I do that in Docker Desktop and get the services, I can see, let's do this, that it's now exposed on localhost. So what I can do now is from my local machine, just use the MS SQLi and connect to localhost using the SA password and run a command. And there we go. I can hit that SQL instance from my local machine that's running in my one-node Kubernetes cluster just by using localhost. So that means I can carry on, do all my work in SQL Server, and then when I'm finished, I can go ahead and I can just blow everything away. Saying delete SQL Server and get rid of that service as well. So that's how easy it is to get up and running with SQL Server for Kubernetes. Sorry, I'm being blinded here. 1 second. There we go. Okay. So let's jump back into the slides and let's talk a little bit about what we saw happening there. So let's talk about the Kubernetes components, starting with the control node. So this does exactly what it says on the tin. This controls the entire cluster. It has all the components that help us manage and run Kubernetes. So we have things like the kube API server. Now, this is what we interact with when we run kube control commands. It is the endpoint for the cluster. Everything in Kubernetes is basically an API resource. And when we make kube control commands, we make basically HTTP requests to certain URLs that pull information back about those components. So we say kube control get pods. We're actually making a get request to a unique HTTP path within the cluster and pulls information about the pods running in our cluster. We have etcd, which is a distributed key value store. So this is what controls information about the objects that's running in our cluster. So when we say kube API server, get pods, it pulls information back about stuff that's stored in etcd. Then we have the kube scheduler. This is what decides which node our deployments go to. So we don't typically in Kubernetes, you can do it, but you don't typically in Kubernetes say, hey, I want to deploy there, I want to deploy there, I want to deploy there. You just say to Kubernetes, I want to deploy something. And it will go off and it will decide based on certain algorithms where's best to deploy your pod. And that's all done via the kube scheduler. Then we have the kube controller manager. This manages controllers in the clusters. And controllers are responsible for things like responding when a node goes down, making sure the correct number of pods are running in our systems, and mapping services to pods. And then we have the cloud controller manager. Now, what this does is allows the Kubernetes cluster to be able to hook into the cloud provider, if it's running in a cloud provider, and access resources in that cloud provider. Now, you can see this when you run, say, an Azure Kubernetes service and you deploy a load balance service. What that'll do is hook into Azure and say, hey, I need a load balancer for this service, and go off and create a load balancer for us. And what that eventually does is give us an external IP so we can access resources running in Azure Kubernetes service from outside of the cluster. So that's the control node, controlling the cluster. But we don't deploy our own applications to the control node. It's simply there to manage the cluster. We deploy to the worker nodes, which are responsible for running and maintaining our pods. So this is things like the kubelet, which is an agent that runs on all Kubernetes cluster nodes. The kube proxy, which does things like map services to pods. And Docker. This is our container runtime. This is what's actually spinning up our containers in the background. So we've all spun up containers in Docker. So when we're spinning up containers in Kubernetes, what's happening is the container runtime is spinning up containers in the background. Now, just this morning, I was reading the Kubernetes version 1.20 notes. And actually, Docker is going to be deprecated in that. So in a future release, they're going to remove support for Docker, and we'll have to use a different container runtime, something like containerd maybe. But for now, we can continue using Docker to spin up our applications on our worker nodes. Okay, so we have our control node controlling the cluster. We have our worker nodes where we deploy our pods. I keep saying that word, pod. What does that mean? So in Kubernetes, we don't deploy individual containers. We deploy what's called pods, and they're the smallest unit of computing in Kubernetes. They are a group of one or more containers. And the way I like to think of this is the Docker icon's a whale. A group of whales is a pod. So a pod is what we deploy. It's the smallest unit that we do. So when we spin something up like we did in the first demo, we're not spinning up a container, we're spinning up a pod. And within that pod, that container is running. And every container in the pod has shared storage and network, and it holds the specifications of our containers. So we have our control node controlling the cluster, our worker node, where we spin up our pods, and then we connect to those pods using something called a service, which is a layer of abstraction over a set of pods. Now, the reason we do this is that pods in Kubernetes are mortal. They die and are reborn. And when they're reborn, they come up within the cluster with a different IP address. And that causes a problem for us, because if we're connecting directly into the pod itself via its IP address, it dies and comes back up, we've lost our connection. Services provide a layer of abstraction over the pods and gives us a stable networking endpoint. So we don't connect directly to the pod, we connect to the service, and it routes our connection through to our pod. So those pods can die and be reborn, come up with different IP addresses all the time, and then we've got a stable connection. And we have different types of services. We have cluster IP. So the service comes up with an IP address that's only accessible within the cluster. We have node port. The service is exposed on a different port on all the nodes in the cluster. We access it via the node IP address and the port on the node. Load balancer. So we'll see this, as I mentioned, in AKS, you'll see this. This will actually spin up a load balancer in the background, give us an external IP address so that we can access applications in Kubernetes from outside of the cluster. And in Docker Desktop, this just gets represented by localhost. And then we have external name, where we can actually map our service to, say, a DNS record, and we can use that instead to connect. Okay, so we have our control nodes controlling the cluster, our worker nodes, where we run our pods. Our pods are where our containers run, and our services are what we use to connect to our pods. Now, in the first demo, we used an imperative method to spin up SQL Server. We told Kubernetes what we wanted and how to do it. We said, kube control, run this with these environment variables. But that's not the only way that we can deploy applications to Kubernetes. In fact, it's probably the worst way. A better way is a declarative method in which we use a YAML file to define what we want to run and just push that into Kubernetes and let Kubernetes work out what it is. And I've got an example YAML file here to spin up SQL Server. So we start off with an API version, kind of deployment, which is the type. This is going to be a type, which is a deployment. And then we're starting off with some metadata. We're going to give it a name. So we're going to call it SQL Server. Number of replicas, 1. We just want one pod running SQL Server in this deployment. Now, what we're doing here is Kubernetes has this concept of running state versus desired state. And it's constantly checking between the two to see what the difference is. So in this YAML file, we are defining our desired state. When we deploy it into Kubernetes, it becomes our running state. And when it's checking between the two, if anything happens to our running pod, the running state no longer matches the desired state, and Kubernetes will automatically fix that for us. There's more built-in high availability. So not only if a node goes down when our pods move, if something happens to that pod, another one will get spun up for us. So that's our replicas. And now here we spec out the containers that we want to run in our pods. So we're starting off with a name. We're going to call this SQL Server 1. An image. We're going to say this one is going to run SQL Server 2019 CU4 Ubuntu 16.04. Okay, it can be, for the demos, we'll use CU5, but for this, I've left it as CU4. Opening up some ports. On the container, we're going to open up port 1433, the default port that SQL listens on. We're going to specify some environment variables. We're going to set the SA password and accept the end user license agreement. Now, I know having the SA password in clear text in a YAML file like this isn't exactly great, and there are things we can do about that, which we'll see in a later demo. But for now, I'm just going to leave it as is. And now we define our service. So we've defined our deployment, we've defined our container. Now we're going to define our service so we can spin up something that will give us an external IP address that we can connect into SQL from it outside of our cluster. So I'm going to give it a name, SQL Server Service. Opening up some ports. So we have port 1433 and target port 1433. What this is doing is saying that anything that hits our service on port 1433 will be routed through to our pod onto port 1433, and we can connect to SQL Server. This is our selector. This is how we map the service to the pod. And then we have our type of load balancer, cluster IP, node port, external name. Here, we're going to go with load balancer. Excellent. So let's go ahead and let's use a declarative method to spin up SQL Server in Docker Desktop. So let's make sure I'm in the right cluster. Always helps. Going to navigate to where my YAML file is. And let's have a look at that YAML file. So it is pretty much exactly the same as the one in the slides, but we've got a kind of deployment, and we have our image here. The only difference is this is CU5 Ubuntu 18.04. Our container port, our environment variables, and yes, I know that is a very bad idea, but for now, just leave it there. And then we have our service. So instead of saying kube control run, what we can say now is kube control apply. Yep. SQL Server.yaml. So all we're saying is not telling Kubernetes what to do. We're just saying take this YAML file, work out what's in it, and deploy it into the cluster. There we go. We can see our deployment is created and our service is created. We can have a look at that. There's our deployments. SQL Server, ready, up-to-date and available, all ones. Looking good so far. And let's have a look at our pods, where our container running SQL Server actually is. And we can see status there of running. I can actually get some more information on my pod if I do output of wide. I get some more here. I can see its actual IP address, what node it's running on. But I'm mainly interested is the status of running. I want to get even more information out of that pod. I can describe it. I can say kube control, describe pods. This gives me a whole bunch of information about the running pod and then the events that have happened with that pod since its startup. And we can see the scheduler kicking in here and work it out where my pod is going to be deployed. It hasn't got much of a choice because it is a one node cluster, so it's going to go to Docker Desktop. I have the container image there already present on the machine. If that container image wasn't there, it would have to go off and pull it down. So it's a good idea when you spin up a multi-node Kubernetes cluster to pre-pull all your images down to your nodes. Because if you have a failover and the pod moves to another node where the image isn't, you'll be waiting for that image to pull down before your pod spins up, which will slow down your recovery time. And for SQL Server, the images can be fairly large. I think it's about 1.5 gig for SQL Server. Actually, let's find out. Where is it? 1.5 gig, yes. So for a container image, that's kind of gigantic. So we'd have to wait for that to pull down before SQL spun up on the new node in the event of a failover. So pre-pull down your container images. Okay, so we've described the pod. Let's have a look at the service. There we go. We SQL Server service, type of load balancer, and again, it's exposed on localhost. So I can test my connectivity with MS SQL CLI and see that I can connect in. There we go. Version 2019 CU5. Let's create a database. Just a database called test database. There we go. Might complete successfully. Let's have a look at it. Make sure it's there. Let's do a select name from sys databases. There it is, test database. Okay. Right, what we're going to do now is let's have a look at that pod again. And let's test that high availability. Let's test that running state versus desired state functionality that we were talking about. What we're going to do here is grab the pod name and then say kube control delete pod. Now, what's happening here? That was quicker than I thought it was going to be. The running state no longer matches the desired state, and Kubernetes should automatically fix that for us. So let's have a look. Let's see if that pod's come back up. And there we go. We have a new pod. We can see age of 14 seconds with a new IP address. So Kubernetes realized that when I deleted that pod, the running state of my deployment no longer matched the desired state. spun me up a new pod because of that replicas 1 in the YAML file. That pod's come up with a different IP address. If we were connecting directly to the IP address of that pod, we'd have lost our connection. But as we have our service, I can continue connecting in with localhost, the external IP address that's been given to me by my load balance service. What's happened there? We've lost our test database. Now, the reason for that is that we haven't configured any persistent storage for our pod, SQL Server. So when I deleted the pod, Kubernetes realized that the running state no longer matched the desired state. But when it spun up the new container, it spun it up from the image, and that image has no knowledge of that test database. So that test database is gone. And when I mean gone, I really mean gone. There is absolutely no way to get that back. And for SQL Server folk like myself, I find that kind of terrifying. So what we need to do is configure some persistent storage for our SQL Server deployments. And let's go ahead and look at how we can do that. Let's just do a little bit of tidy up. There we go. Jump back into the slides. Okay, so let's have a look at how to persist data for SQL Server running in Kubernetes. Now, there are a couple of concepts here. The reason we want to do this, as I said in the demo, is we have the same issue with Docker containers. Data changes not on a persistent volume will be lost. So container spun back up, pod spun back up, that it spun it up from the image. That image had no knowledge of the data changes we'd made creating that database. So it came back up, we lost all the data changes that we made. So let's have a look at a couple of concepts, starting with persistent volumes. So these are Kubernetes persistent volumes. And all persistent volumes is a piece of storage in the cluster. But the key point here is that its life cycle is independent of the pods in the cluster. So those pods can be spun up, spun down, spun up, spun down, deleted, rebuilt, whatever, gotten rid of. We still have our storage. Its life cycle is independent. It's not affected by anything that happens to the pods. And we can deploy persistent volumes either dynamically using something called a storage class, which I'll show you, or statically, which means we have to go and create them manually, which, okay, yes, you can do it, but it's kind of a pain, and it's much easier, especially if you're using something like a managed service as a Kubernetes service, just to create them dynamically. So that's persistent volumes. You've got one more concept to go through, and that is persistent volume claims. Now, persistent volume claims are a request for storage by a user, such as myself. We request size and access type, and there's things like read write once, read only once, and there's another one which for some reason my head's not working this morning, but there's 3 different types. For SQL Server, we typically go with read write once, which means only one node at a time can write to our SQL instance, which is what we want. So we have our persistent volume claims, which is a request for storage for the user, and the pods reference the persistent volume claim. They don't reference the persistent volumes at all. Kubernetes is infrastructure independent, so it doesn't want to reference persistent volumes. We want to keep that separate. We reference the persistent volume claims, and the specific persistent volume claims get mapped to persistent volumes when they're created. And we'll see that in a demo coming up. So I mentioned that we can create persistent volumes dynamically. We don't have to specify and build them manually. And the way we do that is by creating something called a storage class. Now, a storage class is exactly what it says on the tin. It is a type of storage or class of storage that we basically configure within the cluster. And this example here is for Azure Kubernetes service. So we have a type of Azure disk, provisioner, Kubernetes.io, Azure disk, and then we have some parameters, standard local redundant storage, kind of managed. So that's specific to Azure. Once we have our storage class, we can then create a persistent volume claim, and in the background, it will spin up a persistent volume for us dynamically. We don't have to manually create that persistent volume. So we have a kind here of persistent volume claim. Going to give it a name of MS SQL data. Access mode of read write once. Storage class name of the storage class we just created, Azure Disk. And then a type of storage. And we're going to go with 1 gig. I'm going to go with 1 gig for the demos because it's obviously going to create this dynamically for us. If I went for, say, 100 gig, we'd be sitting here for a while. But we'll go with 1 gig, and that'll spin up to 1 gig persistent volume dynamically in the background. So that's storage. Now, I mentioned in the last demo that having your MS SQL SA password in plain text in a config file, probably not the best idea in the world. So we need some way to hide that in our YAML files. We can do that with what's known as a Kubernetes secret. So we can say kube control create secret generic, call it something like MS SQL, and then we specify from literal SA password testing. So once we create that, we can then reference it in our SQL Server deployment YAML file. So instead of having it in clear text anymore, we say value from secret key ref, name MS SQL, key SA password. And that means we don't have to have our SA password in clear text in a config file. However, there is a massive gotcha with secret. Well, it's not really a gotcha, but it's something to be aware of. And we'll have a look at that in the demo coming up. Okay, so that's using the secret key ref. Let's have a look how we reference the persistent volume claim in our YAML file. So the first thing we do is we pick a path to mount our volume, and we're going to, go with var opt MS SQL. This is the default location that SQL Server is deployed to. Under here, you have data logs folders with all the system databases and things like that. And then under here in this volume section, give it a name, and then we reference our persistent volume claim, and that's it. That is how we slide a persistent volume underneath SQL Server's default database directory on Linux, and then we can persist our database from one pod to another. And we'll see that in this demo. So, okay, what am I doing? Make sure I'm using the right cluster. Am I in the right location? Excellent stuff. Okay. Now here, I'm going to create a storage class, same as we saw on the slides, but it's a little bit simpler because this is just Docker, Docker desktop. So I'm just creating a kind of storage class, type of storage class. I'm going to give it a name, test-storage class, and the provisioner, which is docker.io host path. So nice and simple. I'm going to go and use kube control apply. There we go. And let's have a look at this storage class. View storage class, get SC or get storage class. And there we go. There is our new storage class. Now, I didn't have to create that. I could have used the default, but I kind of like showing people step by step. So I didn't want to just rely on what was there. I wanted to create it new. So there we go. We have our storage class there. So now we have our storage class, we can create our persistent volume claim. So type of persistent volume claim, give it a name, read write once, only one node at a time can hit our persistent volume, which is what we want for SQL Server. We don't want multiple writes coming in from multiple locations. Referencing our storage class, and then we're going to give how much we want, and we want 1 gig here. There we go. Nice and quick. So let's have a look. We can see our persistent volume claim. Capacity, read write once, and we can see a status of bound, which means we have our persistent volume as well. We can see capacity access mode, reclaim policy of delete. You need to be a little bit careful here. That's the default one that's come up. What that means is if I delete the persistent volume claim, in the background, it will delete my persistent volume, which maybe I don't want. Maybe I wanted to be able to delete the persistent volume claim and keep the persistent volume. So I could change that to retain if I wanted. But this is a demo. I'm lazy. I want to be able to tidy up nicely. I'm going to leave it as delete. I actually want to find out where that persistent volume is. I can describe it, and I can actually see it where it's on my system, and it's all the way down in here. Now, Docker, because this is Docker Desktop running on WSL2, that might not actually be correct. There might be some other jargon here. But if you run this on, say, Kubernetes node, that'll tell you where your persistent volume is. Okay. Oh, we want to create that secret as well. So let's create that secret. Let's see if we can get that information out. So we can get secrets. There's my secret, MS SQL. Let's see if I'll describe that secret. Let's see if I can get that. There we go. I can't get at that value. However, if I use the Kubernetes plugin for Visual Studio Code, wait for it, come to Docker Desktop, down to configuration. Oh, hang on, I need to do that. No, I don't want to install. Go down to secrets, MS SQL, SA password, boom. There is my SA password in clear text. Docker secrets are encoded, not encrypted. So even though this is a good way of not having your SA password in clear text in YAML files deployed everywhere, they're not as safe as you might think. So just be aware that they are encoded, not encrypted. Anyway, let's get rid of that. Now let's have a look at our YAML file for SQL. Exactly the same as in the slides. So same as before, we have a replica of 1, given some names, SQL Server, our image, our container port, accepting the end user license agreement, secret from SA password from our secret, and then where we're going to mount our volume, and then referencing the persistent volume claim. And then the service is exactly the same as before. Type of load balancer, protocol port, TCP, and then mapping port 1433 on the service to port 1433 on the pod. Okay, so let's deploy it. Let's go. Deployment created, service created. SQL Server up and running, all available, looking good. Is our pod up? Should be. Yes. And our service. There we go. External IP, localhost, as before. Okay, so let's connect, make sure I can connect using localhost. Let's just select that version, standard stuff I always use just to test the connection in. There we go, it's come back and respond. Now let's create our database. So create database. That should come back. Excellent stuff. Okay. Make sure it's there. There it is. Okay. And now we can check where the files are. Well, this is one of the reasons I love the MS SQL CLI, by the way. The output, absolutely fantastic. And look, we can see it's created on var opt MS SQL data, and this is where we slid in our persistent volume referenced by our persistent volume claim. So now, I'll get the IP address of that pod, 3.57. Grab that pod's name and delete it. Remember now what's happening is the running state no longer matches the desired state. So Kubernetes should automatically fix that for us and spin us up a new pod. And there it is. IP has changed as before, age of 11 seconds. So that's come up from the image, but now we have our persistent volume claim and our persistent volume. So, and we have our service as well. So we're not connecting by the IP address, we're connecting by localhost. And I should now have my database. Boom, and there it is. We've got our database back. So by using persistent volume claims, persistent volumes, we can persist our data changes from one pod to another. So if something happens to the running pod, say the desired state no longer matches, the running state no longer matches the desired state, the Kubernetes spins up a new one, we'll keep our databases, we won't lose them. Now, I will say I do get asked this question a lot. Now, we've got that built-in high availability. That's brilliant. What about backups where I think should I be taking snapshots of my persistent volumes? You can absolutely, but I would 100% recommend that you take normal backups of your database on Kubernetes. It's just another platform for running SQL Server. And like all platforms for SQL Server, backups are incredibly important. So if you're running SQL Server on Kubernetes, you need to say, perform any restores, you need to make sure that if something goes wrong, you can get your databases back. Don't rely on this high availability entirely. Take database backups. What was that? Oh. Nope, that was me checking the agenda earlier. Huh. There we go. A little bit of a cleanup. Deleting the persistent volume claim. Notice I'm not deleting the persistent volume because I had that delete policy, so that'll be gone as well. So if I do kube control, yeah, PV, gone. So maybe if I was doing this properly, I would change this to retain, so I'd have to specify the delete as well. But for a demo, it's good enough for me. Okay, we have 15 minutes left. Excellent stuff. Okay, so that's pretty much everything I want to take you through with Kubernetes. We have our control nodes controlling the cluster, our worker nodes where we deploy our pods where we run our containers, actually running our applications, our services where we use to connect in, and then we have our persistent volumes, which is storage in the cluster, our persistent volume claims that are requests for storage by a user, such as myself, and then we have secrets where we can hide sensitive data. We noticed that that's kind of a lot of YAML files. And okay, managing YAML files, some people don't like YAML. I actually don't mind it. If you use, there is a plugin for Visual Studio Code that'll tell you if your YAML files are incorrect and stuff like that. It's very handy because spaces sometimes can be a nightmare. But another option is using a package manager for Kubernetes. And that package manager is Helm. And what Helm allows us to do is gather up all the YAML files into one easily deployable package, which we then push into the cluster. And the advantages of this are we don't have to deploy individual YAML files at one time. We can version our packages so we know exactly what we're deploying, and we can push them up into an external repository. If you want to know more about Helm, I actually have a Pluralsight course up there. If you Google managing applications in Kubernetes, administering applications with Kubernetes with Helm via myself, it's up there. Have a look. You can check. More than welcome to check that out. But let's have a look at using Helm now. So I'm not going to muck around here. Let's jump straight back into a demo and have a look at how we can use Helm to deploy SQL Server in Kubernetes. So coming back here, get rid of that. There we go. Right. So make sure I'm using the right. And I'm going to confirm Helm. Now, Helm on Windows can be deployed via Chocolatey. So it's nice and easy to get started. And then we go Helm version. They recently had a big migration from version 2 to version 3. Definitely go for version 3, which you'll get if you use Chocolatey, if you're running on Windows. So we are Helm version 3. Now we have repositories in Helm, same as like things like the Docker Hub and stuff like that. And we have one here, it's called stable. And up in the stable repository, we actually used to have a 2017 Linux Helm chart, but it's now deprecated. So we could have used that, but what we really want to be doing is building our own Helm packages. And I do have one just here. And what we can do is have a quick look at it. We come here. All it is I have a SQL Server Helm package. And in the templates, I have a deployment YAML and a service YAML. And the deployment YAML and service YAML are the exact same things we've been working with the entire time we've been working. So it's exactly the same image. I know I've got that there. I haven't put the secret in. So bad, but just it's a demo. And then the service, exactly the same. Ports 143, type of load balancer. So what we do is we drop those YAML files into our Helm package. And we then deploy that package to Kubernetes. So let's go ahead.
10 minutes left.
Thank you very much. Okay, so let's deploy that. We just say Helm install SQL Server. That's going to be the name of our deployment. Link to our package, where our package is, and the version. Boom, there we go. And we are deployed. So we've just got some output here for a simple Helm chart to test SQL Server, no persistent storage, and there's no resource limits set for the containers. In Kubernetes, you can limit the resources available to each pod, so one pod doesn't take all the resources on a node, but we haven't configured that here. Okay, so we can confirm that's up and running by doing something like Helm list. And we can see that that is now deployed. What's really cool with this is when I did that Helm repo list earlier, Helm repo list. Or did I do that the wrong way around? No, it's not right. We can add our own custom repos there. So we don't have to have our packages locally. We could just add them in to our repo list and we can deploy them from the remote source. Really, really cool when it comes to built-in complex packages with lots of YAML files in. Okay, so we've got our deployment. It's up and running. We have a look at our deployment there. Yeah, SQL Server's up. Trainer, yep, pod is up and running. And we have our services. There we go. Same as all the other demos, it is now up and running on a exposed on an external IP of localhost. Awesome. Okay, I'm not going to connect it now. I mean, we could if we wanted to, but it's definitely up and running. So I'm just going to clean up by Helm delete SQL Server because I'm aware I'm going to be running out of time. And we have one more section to get through before the end of the session. There we go. So that's Helm. Definitely check out Helm if you're starting to build complex Kubernetes packages. If you're just deploying SQL Server just to test and play around, Helm might be a little bit too much. But if you're starting to look at, deploying SQL Server with a service, persistent storage, a secret, and things like that, you can bundle it all up into one easily managed deployable package and get that deployed into your Kubernetes cluster instead of having to deploy it all separately. Okay. Final section. One of the things I've been looking at recently is something called chaos engineering, or it's kind of a buzzword for resiliency testing. And what chaos engineering is basically experimenting upon a system to see if it reacts the way we expect it to when that system encounters failures. So, for example, we've been seeing a lot of the running state versus desired state in the demos. Kubernetes compares the running state to the desired state, mapping between the two. And if there are any inconsistencies, Kubernetes automatically fixes those for us. And we can test that with chaos engineering experiments. We can blow pods away and make sure that Kubernetes is spinning them up as expected. When I did this demo for a while, we were evaluating Kubernetes at the company I work at, and we were running SQL Server on it, and I was showing people how this kicks in. And my boss was, that's great, but we need to get approval from the C-level management. It's very codey, your demos there. Could you sort of jazz it up a little bit? And she's only going, jazz it up, like jazz hands. So he was like, no, maybe it'd be, have some sort of GUI in front of what you're doing and display it a little bit more instead of just having lines and lines and lines and lines of code. I'm like, GUI, okay, GUI, like a web GUI, like a web page where we can control everything. He's like, yeah, that'd be great. Okay. I've got a GUI. Let's use a GUI. And what if that GUI was Space Invaders? This is a project I found on GitHub about a year ago now. It's called Kube Invaders, and it does exactly what you think it does. Those invaders are our pods, and we play the spaceship. And we can use that application to test that resiliency, that high availability within Kubernetes, that desired state versus running state, and making sure it spins it all up by playing Space Invaders. So let's go and let's have a look at that. So coming in here, where am I? I'm on my Docker desktop. What I'm going to do now is I'm going to switch to an Azure Kubernetes service cluster. Make sure I'm in the right place. And what I'm going to do now is I am going to deploy 10 instances of SQL Server. So let's have a look at that. There we go. 10 pods running SQL Server up in Azure Kubernetes service. I'm going to grab that statement, come over here, click watch. Now I can play the game. So I'm going to get rid of that one, get rid of that one. And on the left there, we can see Kubernetes terminating the pods as I'm killing them and then spinning them up. And we'll see the screen refresh. So I've got my 8 pods. Come on, we want to go back to 10. You give me my 10 pods. There we go, back up to 10 pods. So now the desired state of 10 pods matches the running state. Let's kill it again. Let's get rid of some more. Kubernetes on the side there, we can see it killing off the pods as I'm playing the game. Why did that one stay there? Go, there we go. And spinning up those new pods. So, I mean, eventually it will keel over because no application likes to be, constantly killed and spun up, constantly killed and whatever. What's good about this is I can stick it into automatic mode and let it play itself. And I can present this whilst talking about what's happening on the side there. We can see the new containers are coming up as the old ones are being killed via this application spinning it down. So practical applications, not really. I just think this is a little bit of fun just to show a chaos engineering experiment with SQL Server running on Kubernetes. Okay, I'm going to cancel that. And I'm also going to refresh that. Going back into the slides. Clean the demo up. And then finally, well, did I actually kill that? I did, didn't I? No. Oh, yeah, sorry. Okay, finish off the session. We've got some links for you here. The top link there is the link to my GitHub repo for this session with all the slides and the code for all the demos I've been doing. I've got code in there for Docker Desktop, Azure Kubernetes Service, Micro K8s, and just recently the code for running on Raspberry Pis as well. The second link down is a link to a summary I've made of all the posts that I've done on running SQL Server in Kubernetes and Docker. It will and there's a whole bunch of stuff there for you. And the third link there is a link to the Kube Invaders GitHub account. So if you want to check out Kube Invaders, I've also posted a blog on how to get that up and running in AKS. So thank you very much. Hope you've enjoyed the session. And are there any questions?
There are some questions in Q&A if you click on the...
I can't seem to find it. There it is. Right. I'll do. Move that over there. There we go. Okay. Let's have a look. So I would like to initiate SQL Server with huge databases in it. Okay. Well, what I would do is I would deploy SQL Server. I would deploy SQL Server to Kubernetes on your persistent storage, and then pump your data in. So the storage is going to be retained, but your pods will go back and reference it. So don't put the SQL database in the container image itself. Have it on, spin it up like we did in the third demo, where we have persisted volumes. A huge database can be on that, and then your application SQL Server will reference that database. What containers and Kubernetes do is separate out the application from the data. So we kind of seem to think that they're always the same thing, really, in virtual machines, but they're not. We have our data, and we have the application. Application SQL Server can come along, reference that data. We can blow it away, and then have another one come back and reference it. So it's the cattle versus pets thing. At the moment with virtual machines and things like that, we treat the SQL Server as pets. Whereas it comes into Kubernetes, they're treated as cattle. Where we get, we don't look after them as much. We get rid of them, bring them back in, get rid of them, bring them back in. So if you want to have a huge database of SQL Server in Kubernetes, firstly, really evaluate that because it might not be the best technology for you. But if you want to go with it, definitely don't put your databases in the container image. Always have your persistent volumes there. The second question, how to start more than one SQL Server with the same database on persistent server. SQL Server acts as SQL Server would. It does not like having two instances hitting one database. So you can't really do that, I'm afraid. If you're thinking you have one pod running and one pod not, you'll get lock conflicts. And I have tried this a few times now. You won't be able to get those two things hitting each other. You have to have one instance hitting one database. You can spin up persistent volumes with more than one node being able to hit the data on that persistent volume, but SQL Server will not like it at all. And then how to synchronize database changes between databases on different pods. Like any other SQL instance technology, I mean, you can use clusterless AGs. I'm not too sure how well they work on Kubernetes. Then you have replication as well that you can use. Yep, so remember, it's just another platform that SQL Server is running on. There's no actual different changes to how SQL Server runs here. So SQL Server behaves as expected. We're just doing things in Kubernetes. We're taking advantage of things like Kubernetes high availability and little bits to get persistent storage in there. But SQL Server itself is basically normal SQL Server. Okay. Do we have any more? Let's have a look at the chat. Okay, great. I hope that, yep, I can see that answered your questions. If you have any more, I think I'm over time now. So I'm going to say thank you very much and enjoy the rest of the day.
Thank you. Have a nice day.
You too. Bye now.